Okay, so we're continuing on our discussion of meta-characters in the context of regular expressions. The idea being that we have a set of, when we're using tools like grep, like many text editors, like a variety of programming languages, and an even larger set of programming language libraries that support regular expressions. Those regular expressions being used to match patterns of characters, strings that match some patterns. When we use these regular expressions, we can specify not only literals, just standard strings. We can use special characters, or so-called meta-characters, that help us build up very complex patterns out of simple pieces. We've discussed a number of them. I'm going to go on to discuss quoting. When cases where we have these special meta-characters in the strings we want to match. We actually want to match something like a star, we want to match something like a dot, or we want to match something like a begin bracket, which has special meanings normally within regular expressions. How do we do that? Well, just as we saw earlier in a 214 lecture for preventing command line interpretation, we have a way, a very similar way, in fact, to prevent interpretation by the regular expression machinery of a given character. Specifically, we use a backslash. Now, it's no accident that this convention originated simultaneously in three pieces of software. These regular expression matchers, such as fgrep, egrep, and grep, within Linux, within the Linux command shell, and within C, the language C. These were largely defined by the same group of people, the same general community, and in all cases, the backslash character is a quoting character. It basically prevents, it can be used to either in C to indicate a special character, or here in Unix shell and in regular expression to prevent special interpretation of another character. Okay, so if we have a meta character like star, we can prevent interpretation of it by a backslash. So, for example, if we want to look for all cases where the sequence DG is followed by a dot, we can't just put a dot. If we just put the dot there without the backslash before it, it would match DG followed by what? You should go watch that lecture if you haven't already. That is, it could be followed by any single character. Here, we're saying D and G has to be followed by the dot character. This backslash says, hey, don't interpret this dot as something special. Just interpret it as a character. Okay. So what we're matching after that has no backslash. I mean, it's just DG dot. Backslash just right away to make clear our meaning, that we didn't want the dot to be interpreted specially. So if we look in Linux.words, again, if we're in the right folder for that, I described that earlier, it'll find two words, for example, with DG followed by a dot, anywhere in the line. So here, building, I don't know what that is called, communication dialog, I don't know. So there's two of them, and meanwhile, if we look for DG dot, in other words, something which has the character sequence DG and then some particular single character, there's 1,406 of those, so there's a lot more. Very, very similar convention used for the shell, and also for the case of this, for the case of regular expressions. Okay. It's notable here that in these examples here, we're putting these in single quotes. Single quote is doing what here? Well, it's preventing the shell from seeing this backslash and interpreting it. So remember, the shell is also looking for things in strings. If we put this in double quotes, the shell will be looking inside this. If we didn't put in any quotes at all, it'll be looking at it when interpret that backslash character. So here, these single quotes prevents the shell from mucking with the interpretation, from futzing around with what's in there, and that guarantees that grep will be able to see it and be able to know, okay, this backslash is for grep. Okay. So what would this sequence do? If we grep for this regular expression within here, what would that look for? Well, let's kind of tease it out. Let's parse it out. So what is it looking for first? Well, it's looking for a sequence of 0 or more characters, followed by what? Followed by a dot character. Backslash dot, remember, tells regular expression, tells grep, hey, use whatever's after this. Even if it has a special character, don't pay attention to it as a special character. Just treat it as a character. So we're looking for any sequence, 0 or more characters, followed by a dot, followed by any sequence of 0 or more characters. So if the dot had been at the beginning of the line for one of these lines, it would have been there too. It would have been just fine. Here, it so happens that in alphabetical order, we have this A dot first. That was matched by this piece. The dot was matched by this piece. We have some others where we have A dot. Okay, so A gets matched. For the first match, A gets matched here. Needs that A to match against this dot. So this has got to match the A. And then the rest is all matched by this component. Now we can find other matches there too. For example, another match within this same line, which grep actually doesn't need. As long as it found one, it outputs it. But another match in this line would be, for example, this one, and this one, and this one at first. This guy, this backslash dot would match this guy. And this following dot star would match this other. So this final one, that would be another match. And it's not even the only one either. There's another one, for example, stretching all the way here. First one, this guy matches all of these out here. The next one matches dot. And this thing, dot star, well, it can match 0 or more characters, so it matches 0. That's perfectly legit as well. Okay, so that's a bit on the coded character in grep. It's a little bit confusing because it's the same coded character as is used in shell. In this case, it's special delivery to grep because it has these single quotes around it. The shell isn't mucking with it. It isn't messing with it at all. It isn't frobbing it. Okay, so thanks very much.